During the University of Kansas Research Experience for Teachers Shift Ed program, my team developed lessons to investigate the carbon cycle by analyzing carbon fixation and biomass combustion using a small burner that allows for temperature, particulate matter, and CO2 data collections. Our team continued with previous year's work with researchers at KU to investigate the burning of algae as a dry fuel source to co-combust with coal. Some coal power plants currently do co-combustion with waste products such as pine sawdust in order to decrease the amount of CO2 put into the atmosphere from fossil fuels. First, algae and coal pellets had to be designed so they could be burned. Next, the pellets were burned and analyzed with a variety of data, including energy outputs, particulate matter, and CO2 concentrations. The image on the right shows the industrial burner that was used. We also did some calorimetry work, which you can see on the left, as well as CHN analysis. Again, building off previous year's work, we developed a burner suited for the classroom in size and cost. It is fitted so that within one burn you can collect energy, particulate matter, and CO2 data. Pellets are placed on a lighter. While burning, a calorimetry can set above the pellet collects temperature data. A tube is hooked to a pump which pulls the air into a bromothymol blue lime water solution which contains a pH probe to collect CO2 data. There's also a filter fitted to the top can to collect particulate matter for analysis. We then put together a project made up of lessons centering around the carbon cycle. This burner is inexpensive to make, and you can see the comment section below for a link to video instructions. In part 1, we investigated photosynthesis and respiration in Alodia. Students used an inquiry activity to figure out how to indicate bromothymol blue works. They determined that an increase in CO2 turns the solution yellow and a decrease in CO2 turns it blue. As a class, we then burn a coal pellet to show that CO2 is given off and changes the bromothymol blue solution. With this information, my students were challenged to develop a dry fuel source in order to burn as a replacement for co-combustion with coal. They needed to think about how to obtain the fuel, create it into a pellet, and then burn it. In the first year of the project, some students had ideas of waste products to use, such as food waste, soybean chaff, lawn clippings, or manure. Other students wanted to grow their fuel, such as switchgrass or algae. Students had to determine the environmental costs of their fuel by creating a life cycle analysis. They looked at how the environment was impacted at each step of the process, including obtaining their fuel source, transporting it, and the waste products produced. With this information along with the burn data, the group set up a poster presentation. Students shared their information with their peers and teachers in the building. We were also able to share with an employee of Westar Energy who had a great question and answer session with the students. Here are some of the standards that this project helps address. This project allowed my students to become scientists and engineers to investigate, design, and test their new fuel source. A link to this lesson and others can be found in the comment section below.